Okay, so the problem says simplify 4x in brackets squared plus 5x squared. Okay?
Yeah.
Okay, so the thing is, let's focus on this 4x squared for a second here. Okay? And I feel like this is something that really needs to be understood as opposed to just applying the rule. I mean, the problem is when you learn it and you just apply the rule, you just square the 4 and you square the x, okay? So you get 16x squared.
Mm-hmm.
And that's all very good, especially when you remember the rule. But then when you forget the rule, then you can't remember what the rule was, or you make up some other rule, okay? So I think it's better to just actually understand what it is and not tax your memory for no reason, okay? So a little bit of this is going to look a little bit unnecessarily complicated, but that's only because you're probably trying to memorize it. If you try to memorize it, then it is unnecessarily complicated. You could just remember the original rule, right? But if you want to figure it out, this might be how you do it. So squaring it, okay, is just timesing the number by itself, right? So you have 4x times 4x, right? So we're not memorizing any rules, we're just using the definition of a power, the square. Okay. Okay, there's another thing with the bracketing. Okay, with the bracketing, I never would have done this when I was in school, but it is a thing. And this may be sort of a little bit over the top if you're not used to it. So when you multiply numbers together, you know, this is a number x multiplied by 4. You do this multiplication first, then you do it here first, and then you multiply the result, right?
Yeah.
So there's this rule called the associative rule, which says you can sort of bracket these in a different way. Okay, so you can actually, for example, do it like this. You do 4x times 4, okay, and then times by x, and that would be the same thing. Okay, or you could even, and you could also swap the order. That's called the commutative law of x and 4. So you can multiply two numbers in whatever order you want. So that's a little bit different to bracketing. So I could change it to that. Okay, but if you want to kind of jump to the chase, I'm basically just multiplying 4 and 4 together and x together, and I'll end up with 4 squared, which is 16 times x squared, right? But let me do it like this. So then I can change the bracketing here to be x times 4 first, and then times by x. So that'll give me a 16, okay? So that's 16. And then 16 and x, you can actually do it in another order, right? So I'm going to write it here to fit it in. You can make it 16x times by x, right? And then you can make it 16 times, this is doing the regrouping, x times x. And so now that'll become the x squared. 16 so times x squared is, what 16x squared is?
16x squared is...
Yeah. So you first, so 16x squared means you first take x and times it by itself, okay? And then you times it by 16, okay? It does not mean 16x all squared, which is what we use the brackets to mean, okay? And now 16x squared is of a like term. It's like it's like terms with 5x squared. So you could just, so 16 lots of x squared can be added to 5 lots of x squared to get 21 lots of x squared. Okay? And you know, you should check this. Maybe you could put in the value x equals 1, right? If x equals 1, then this is, you know, 4 times 1, which is 4, squared is 16, 1 squared is 1 times 5 is 5, plus together is 21, right? And then 1 squared is 1 times 21 is 21. So that checks out when x equals 1. It doesn't mean it's right, it just means it's not immediately wrong. You can put x equals 0, okay? 0 makes that 0, that makes that 0, this is 0. So it's true for x equals 0. And I guess the interesting thing is when you have sort of x squareds like this, if you check it for 3 things, then you actually do know it's right, but that's a more complicated reasoning, okay? So if you check it for x equals 2, for example, you get 2 squared is 4, 4 times 21 here, right? Which is 84. Here you get 2 squared is 4 times 5 is 20. Here 2 times 4 is 8. 8 squared is 64. 64 plus 20 is 84. So it's actually true for x equals 2 as well. Okay. But usually if you make a mistake, your first 1 or 2 values of x will make it very obvious that you've made a mistake.
Yeah.
Alright?